In this video, we will discuss about intervals. As the word shows that this is a thing that lies between two elements or objects. So we move on to the definition of interval, that is a subset of real line that contains at least two numbers and contain all the real number that lies between them. I used a short form for between word. So, what is the example of intervals so that you can get a clear idea? Like x is greater than 4, that all the elements lies in x, but these elements, these numbers must be greater than 4. Suppose this is our 0 in real line and here lies our 4, and between 0 and 4 we have 1, 2, 3, and from here we can say that x lies over here. X is greater than 4. So all the elements present in it. Let's take another example. In it over this example, x lies between 2 and 4. It may be 3, 3.5, 2.5, but we say that x lies between 2 and 4 numbers. And we take another example, that is 2 and 3. In real line, we say that, and this is our 2 and this is our 3. So all the elements that present between 2 and 3 are also included in this interval, and the numbers that came before 2 and after 3 will also present in this interval because it is a one interval. So we are going to describe a term that is finite interval. Let's take an example of line statement. What is a line statement? That has ends. Suppose I am taking it has 2 and it is 4. It ends at point 2 and it ends at point 4, and it doesn't continues from both sides. Then we can say that it is a finite interval, and only the elements that present between this interval are the numbers and the elements of that interval. And what is an infinite interval? That continues from both sides is called as infinite interval. So what is the example of finite intervals? Suppose this is our line segment that starts from 2 and ends in 3. So only 2 and 3 elements, and the elements present between 2 and 3 are present in this interval. So this is called as finite interval. And what is half open and opened? Intervals we can get a clear idea by discussing this figure. So, solving inequalities. It is a process to find the intervals of number that satisfy an inequality in X. So, these are the finite intervals and these are the infinite intervals. As a figure shows that A and B, two numbers present in this notation, and set description is as set of X numbers values such that A is less than X and X is less than B. Its mean it is an open set. How can we represent it on real line? You can see that it is a real line and both the starting point and the ending point of this interval is a hollow circle. They didn't colored it completely. That shows that it is an open interval. And how can we show that interval is closed? Square bracket is used to represent a closed interval. And how can we describe the set? Set of x interval x numbers such that a is less than equal to x and x is less than equal to b. So then that set will be closed. And here you can see that starting point of A and B point are closed and they make a colored point over here, completely colored point to show the closed interval. Now what is a half open and half open set? So square bracket is used to represent half open intervals. So square bracket and on the other side we use circle bracket to represent half open intervals. So description is like that: set of x values such that a is less than and equal to x and x is less than b but not equal to b, then that set will be equal to half open. You can see from the figure of real line that here they closed from this point A and here they opened from the point B. So they give a complete colored point in at point A and the hollow point at point B. Same is like this. Here is our closed point and here is our open point. And in figure we see completely colored point and hollow point. And in infinite intervals we use infinity sign to show its infinity. So if we say that it is a open interval that has a and infinity sign over here. So we will describe the set as set of x values such that x is greater than a, then that set will be opened. You can see that the infinity is positive. So we can say that x is greater than. We can't use the minus sign over here to show that s is less than a. That's why we represent it as moving towards positive signs. Like here lies our A, that is a hollow point because it is opened, and from here we say that our x values lies over here, positive infinity, and in closed interval from the point A and open interval from the point of infinity. We can say that x is greater than and equal to a, then we can say that is closed, and you can see that they make a completely colored point over here to show that it is closed interval. And we have positive infinity, we can say that our x values lies over here. So same is the procedure for negative infinity, but the point of x lies in the negative values of real line. Suppose this is our B and the point is hollow because it is opened from this side, and we use negative infinity. That's why we indicate the values of x in this direction. And what is the closed form? B is closed and we have negative direction of x values. I am using the same figure to represent the closed interval. And the last one is both positive and negative infinities are present over here. That's why we say that both in both direction our values lie. That is real number set of all real numbers both open and closed. It is open and closed both.